Hello everybody, welcome to Bluemarblescience. This is part 3 of Quantum Eraser, Nathan Oakley, and 5 fallacious flat earth claims. Q and Nathan are going to continue to misunderstand the Coriolis effect in our atmosphere, so we'll see what we can do to sort that out. And then they're going to go and explain to us why you can't have gas pressure without a container. Unfortunately, I did an experiment that proves otherwise. And by the way, do you think those areas of high and low pressure in our atmosphere might be considered pressure without a container? I don't know, we better think about that. Warning! Facial and monitor damage alert remains in effect. Keep those oven mitts handy. Move the monitor back out of punching range. And Gladys, how about some marshmallows? I don't know where they are. You're the one that had them. Come on, Gladys, go find the marshmallows.
Now, I'm going to give you the perfect example of no depth, no scrutiny, no due diligence, blind Wiki Discovery Channel parroting pretender clown Muppets.
But before you do,
hold on.
I just want to get everyone on the same page. So we're talking about an apparent deflection, and I'm going to hopefully get everyone to visualize this with a very simple explanation that doesn't involve somebody on a roundabout throwing the ball. So now imagine that you're on a roundabout and you're spinning around and around on the outside edge of that roundabout, and there are two friends, one at each end of the roundabout, and they, not you, are throwing the ball back and forth. So the ball is most assuredly travelling in a straight line, because if it wasn't, it wouldn't reach the hands of the person on the other side of the roundabout. So they are throwing the ball completely independently of the roundabout. The ball leaves one person's hand, travels in a straight line, and reaches the other person's hand, and then gets thrown back again. Straight line, back and forth. Now, you, the observer in this instance, are on the spinning roundabout, and you are observing the ball being passed back and forth between these two people who are not on the roundabout. And as you observe what is most definitely a straight path, what you see from your position on the roundabout appears to curve. However, it isn't actually curving, it's only an apparent deflection based on you, the observer, and your rotation on the separate reference frame.
Nathan, I know you do your research on Wikipedia, so let's just go straight to that. Coriolis. In physics, the Coriolis force is an inertial fictitious force that acts on objects that are in motion within a frame of reference that rotates. Two guys on the outside of a roundabout throwing a ball back and forth are not in the same frame of reference as the guy that's sitting on the roundabout. That's not how this works. Let's see if we can figure this out. We've got our turntable. Let's put you up over the top of the turntable, Nathan. Let's bring Tootsie in and put her on the turntable, and let's make the turntable spin counterclockwise. Now, you are in an inertial frame of reference. Tootsie is in a rotating, non-inertial reference frame. Let's bring in your buddy, Mr. Magoo, and have him throw a baseball over the top of the turntable. You, the baseball, and that jackwagon are all in the inertial frame of reference, while Tootsie remains in the rotating non-inertial reference frame. Let's get rid of Magoo. Let's bring in Tootsie's cousin. And now let's let Tootsie try to throw the baseball to her cousin. To you, that baseball will look like it goes straight, because you're in the inertial reference frame. But to Tootsie and to her cousin, the baseball will not appear to go straight, nor will it go straight. In that rotating, non-inertial reference frame, the ball most definitely curves.
And it looks like it curves. It doesn't. It doesn't.
Yep.
But by having
Depends on
three
your-
people,
Hey Nathan, did you notice that even Quantum Dum Dum tried to stop you? Even QE realized you had that all messed up. Let's go to one of QE's references here, the Encyclopedia Britannica, and read some of the stuff QE left out. How about this? The Coriolis deflection is therefore related to the motion of the object, the motion of the Earth, and the latitude. For this reason, the magnitude of the effect is given by 2v omega sine phi, in which v is the velocity of the object, omega is the angular velocity of the Earth, and phi is the latitude. I know, I'm sorry, math, boogie boogie boogie, sorry about that. But once in a while it's necessary. A little further down, it gets down to the point. The Coriolis effect has great significance in astrophysics and stellar dynamics, in which it is a controlling factor in the directions of rotation of sunspots. It is also significant in the earth sciences, especially meteorology. Let's go down a little bit. Thus, the Coriolis force figures prominently in studies of the dynamics of the atmosphere, in which it affects prevailing winds and the rotation of storms, and in the hydrosphere, in which it affects the rotation of oceanic currents. It is also an important consideration in ballistics, particularly in the launching and orbiting of space vehicles. Coriolis force is very real. It's just like centrifugal force. It is an inertial force that appears in any rotating frame of reference. I know you guys don't like that, but that's the real world.
What does an actual spin direction of hurricanes have to do with the Coriolis effect, which is an apparent deflection, please?
How does Coriolis affect actual rotation? Well, QE, without Coriolis, you wouldn't have any rotation. If all you had was a stationary atmosphere and a low pressure system, like I'm showing here, air from the higher pressures around that low would flow directly toward the center. But the Earth's not flat and stationary. The Earth is a sphere and it rotates. And that means the further north or south of the equator you go, the slower the speed of the surface is moving. At the mid-latitudes, maybe 700 miles an hour. At the equator, it's around 1,000 miles an hour. What does that do? The Earth rotates from west to east. Air flowing from south of that low-pressure system toward the low conserves its momentum, and it will necessarily move ahead of the low. In other words, it will be deflected to the right. Air from the north of the low-pressure system will conserve its momentum. It's moving slower than the low. As it moves to the south, it will be deflected to the right. Always deflection to the right in the northern hemisphere, resulting in a counterclockwise rotation. The opposite happens in the southern hemisphere. Sorry, fellas, that's the way it is, and your own source and reference confirms it.
Okay, so how do we have a gas pressure, that is atmospheric pressure, without a container to begin with, when the pressure of a gas is the force that the gas exerts on the walls of its container? Can't wait to hear this yarn. You can't have gas pressure in an open system. Married bachelors are more tenable. So basically, please explain how you can have tire pressure without the tire.
Okay, QE, if you want to talk about thermodynamics, let's get away from your usual bullshit about containers and talk about thermodynamic systems. Let's talk about closed systems, open systems, things like that. Let's go to LibreText here, and just so you'll know who these guys are, let me go down to the bottom of the page. They are supported by the Department of Education, UC Davis, the National Science Foundation, etc., etc. Let's see how they define an open system. An open system is a system that freely exchanges energy and matter with its surroundings. For instance, when you are boiling soup in an open saucepan on a stove, energy and matter are being transferred to the surroundings through steam. Got it? Open pan on the stove, boiling soup, exchanging matter and energy with its surroundings. It's open, like a bucket, or like a pipe that's only sealed on one end. What's a closed system? Putting a lid on the saucepan makes the saucepan a closed system. A closed system is a system that exchanges only energy with its surroundings, not matter. By putting a lid on the saucepan, matter can no longer transfer because the lid prevents matter from entering the saucepan and leaving the saucepan. Closed system, pot with a lid on it. Pipe sealed on both ends. Understand, QE? How about this, Quantum Eraser? This was taken from my original video about pressure without a container. You guys jumped up and down after you had already said that the container had to be sealed, in other words, a closed system. You jumped up and down claiming that the pipe is a container, but now you're back to saying it has to be a closed system. It cannot exist. Pressure cannot exist in an open system. Well, there's 24 feet of pipe without a cap on the end of it, holding 0.35 inches water gauge gas pressure. Care to explain that? Tell you what, let me do it for you. Gravity is holding that butane gas in the pipe. If it weren't for gravity, that pressure could not and would not exist.
Number two, how can you have a vacuum that is outer space attached to a non-vacuum Earth without a physical barrier in the same system simultaneously without bludgeoning to a bloody pulp? The laws of entropy, that is the second law of thermodynamics.
Our atmosphere doesn't exist next to a vacuum, nitwit. At sea level, our atmosphere is 760 torr. That's 14.7 pounds per square inch absolute pressure. At 35,000 feet, it's down to 200 torr. If we go to 150,000 feet, we're at 1 torr. At the Kármán line, 327,000 feet, we're at 5 times 10 to the minus 4th torr. If we go out to, say, the surface of the moon, we end up at 3 times 10 to the negative 15th torr. And in deep space, we're at 1 times 10 to the negative 17th torr. Our atmospheric pressure is never existing next to a vacuum, and a vacuum, by the way, is a man-made conception that is convenient for us because we live in atmospheric pressure. It is convenient for us to think of 14.7 pounds per square inch absolute as being zero gauge pressure. In our atmosphere, pressure does not exist next to a vacuum. Pressure simply decreases until we reach the pressure of space, or about 1 times 10 to the negative 17th torr. A balloon at around 300 feet above mean sea level will show a pressure of about 14.4 pounds per square inch. By the time that balloon ascends to 115,000 feet above mean sea level, the pressure is down to 0.09 pounds. Our atmosphere doesn't exist next to a vacuum, as you continually falsely claim, QE. It eventually simply fades into the near zero pressure of deep space. And oh, by the way, you're always so concerned about entropy. We lose about 300 tons of our atmosphere to space each and every day. I think entropy has been conserved. Thank you very much.
Number three, this is kind of fun. How in the world did the Earth form an atmosphere at all in a vacuum from a big bang?
Gravity, you fucking retard! Gravity! Have you ever heard of fucking gravity?
Well, let's see how you did. You guys started off with your aviation myth that basically says an airplane needs to descend in order to maintain altitude. How in the hell do you descend and maintain altitude, QE? Busted. Then you go to the salt flats in Bolivia and try to convince us that they are absolutely flat, but you do that by showing us that you do not understand what relief means when it's used with respect to a geographic feature. Elevations are measured above mean sea level, QE. Mean sea level is reference to the geoid, QE. Busted. Then you go after SAMs and radar, and you're trying to tell us that the range of the missile is the same as the range of the radar. Do you really believe that? I know we don't. Busted. Coriolis force, though, is my favorite. Nathan has two nitwits throwing a ball back and forth in an inertial reference frame over the head of Huey in a non-inertial reference frame and talking about the ball curving or appearing to curve. Busted. And finally, atmospheric pressure, and you guys actually got something right. You can't have pressure in an open system. Gas pressure will not exist in an open system. That pipe of mine didn't have a cap on the end of it. That's an open system, and the only reason it is not totally open is it is subjected to gravity. Busted. Well, I'll tell you what, thanks for watching, folks. That's the end of this series. I had a lot of fun doing this. I hope you enjoyed watching it. If you did, please hit those like and subscribe buttons right down there under the little red arrow. And we'll catch you guys on the next one. Hey, Gladys, we're out of here.